Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. Here is my profile. So let me give you my introduction. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and we were discussing AOD. In this session, we'll continue that. Hello Dhruv. Yeah, what do you want to confirm? So as you know, Unacademy is India's largest online learning platform. And if you are preparing for IIT-JEE, then you can have two types of subscription on Unacademy. One is Plus subscription and another is Iconic subscription. So what is Plus subscription? Let me tell you. If you have Plus subscription, then you get unlimited access of on the platform, and you can watch live sessions of all the educators on Unacademy. You can join some course and start your preparation for IIT-JEE. Every week, many courses are. Every week, they start a lot of courses, fresh courses like algebra, coordinate, or you can already you can join all ongoing course also. And if you have missed something, you can watch the recorded sessions as well. That's up to you. So this is the unlimited access in which you will get unlimited access on the platform. There's no restriction. You can follow educator of your choice. That is called, so this is Plus subscription, and you can take Plus subscription for 1, 3, 6, 12 and 24 months. 12 months it is 38,500. Dhruv Dixit, I don't have any idea of that. I mean, that kind of information is not between the teachers, so I don't have that information. All right. And 24 months, 24 month subscription you can take in for 56,000, and in all these subscriptions you get 10% discount. So use this code, referral code JEET1, and final price will be here. Here I was just giving the introduction part. I thought it will be 3 o'clock by then. All right. Good afternoon. Good afternoon. So now second is Iconic subscription. In this you get all the benefits of Plus, and apart from that you get a personal coach who will guide you throughout your preparation for IIT-JEE or other top exams. Your test analysis will be done in a personalized manner. Your feedback will be given to improve your time management and exam approach. Your study planner will be customized. So all these additional things you are getting in Iconic subscription, and these are the charges for Iconic subscription. Now 56,000 for 1 year, and you get 10% discount in this using the same referral code JEET1, and 86,000 for 2 years. All right. Now this is Unacademy's learning app which you can download from Play Store. And if you don't have any subscription, then you attend special classes anyways. So unlimited special classes you can attend on the platform every day. A lot of educators take special classes. So you just make your account and start learning. So shall we begin, Raghav? Shall we begin? All right. So first I will tell you point of inflection and concavity, and after that we will do maxima minima. All right. Just a moment. No, दिवाली के टाइम्स पे YouTube classes नहीं रहेंगी. I mean 14, 15, 16 I will not be taking. I will take only special classes those days, and that too on 14 and 16, not on Diwali. Mm-hmm. What do you mean critical points? I mean, critical points you include in some questions or some not. What type of questions? Critical point means you are the f dash. Okay. No, no, no. See, I'll tell you what. See, if function is always increasing, like generally, like function is this, like this. Okay. Then this point and this point you will not include. Okay. If this is A and this is B, then we'll say that A to B it is decreasing, and that A to B will be open. A to B. So that's why we do not include this point, because you can see at this point is maxima and at B it is minima, right? So at B it is not, A it is not increasing and B it is not decreasing, right? A and B. So that's why we leave these points. When function is increasing, then it decreasing, then increasing, then decreasing, right? So you just leave those points of extremas and open interval laga ke, and you can say that this function is increasing in this interval. And yeah, but in some cases, like this is the case, like it is increasing, and then slope will become 0, and then it is again increasing, like x cube, okay? So you can see this is also a critical point, 0 for x cube, at x is equal to 0. In this case, you can see there's a difference. This point is not point of maxima and minima, right? So if slope becomes 0, and slope does not change its sign about that point, slope is 0, like f dash of x1 is equal to 0, and you see at x1, around x1, first slope was positive, then became 0, and then again it is positive. That means function is increasing at 0, okay? Then you will include this point x1. Hello Jia. Jia Sinha, you are the same Jia who attend special classes. All right, okay. Actually, I did not know your full name. And see, if dash x, if dash x is equal to, if dash is 0 and it changes its sign, like if dash x is positive here and then negative, that means at x is equal to x1, at x is equal to x1, it is maxima, right? This we are going to do today. Okay. So you can see in this case, sign does not change. F dash is positive here, F dash is positive here. And at this point it is 0. 11th के लिए not today, but we'll keep some sessions if you want after Diwali. So if you want to do some topic, you can let me know, like permutation, combination, or anything. I will plan session for that. So if there's a peak or lowest point, then it will not be counted in increasing and decreasing point, right? But if it is increasing, slope becomes 0 and then again increasing, then it will be counted, okay? Then that point will be counted in uh, monotonic. ये गब्बर कहाँ से आ गया? अच्छा. All right. Oh, Abhinav. All right. I didn't see him. Okay, so now let's begin today. Maxima and minima. So if fx okay, maxima, local maxima or local minima of fx at x is equal to a at some point. Okay, so what is the condition? See, first very basic condition is if f of x1, sorry, f of a, if f of a is greater than f of a plus, that means right hand limit, and also greater than f of a minus, that means left hand limit. Okay, लेफ्ट साइड वाली वैल्यू से भी ग्रेटर है और राइट साइड वाली वैल्यू से भी ग्रेटर है, देन दिस इज कॉल्ड, देन एफ एक्स हैज लोकल मैक्सिमा at x is equal to a. All right, graph will look like this, something like this, like this is one of the point, this is one of the graph. Okay, this point is a, so you can see f of a is here, right? So it has a maxima. Even if you turn the graph, can you tell me, answer this in yes or no? Okay, average like this. Okay, then you can see, is it a maxima? Can you tell me, is f of a is a local maxima? Local maxima. Yes, it is still a local maxima, because you can see left hand limit and right hand limit, left hand limit and right hand limit both are here, both are approaching to this point, which is smaller than f of a, right? F of a is this point, f of a is this point, so of course this is a local maxima. Okay, even if you can draw graph like this, this graph, then graph can go up again, and this point, right? Can you see, is that a local maxima? Yes, this is also a local maxima, right? You can see this is f of a, and this is greater than right hand limit and left hand limit. This is your right hand limit, and at this point it will be left hand limit, right? So f of a is greater than both values, both sides. Okay, so these are some graphs, broken graphs, and obviously, of course, if it is a continuous graph, then graph will look like this, right? So at this point you can see there's a peak, x is equal to a. So for continuous graphs, continuous and differentiable, and only continuous but not differentiable, and then it will be like this, corner like mod of. Okay, so at this point also maxima, local maxima. So all these points are points of local maxima, local maxima, local maxima. Okay, in all the examples I have given, you can see local maxima. Local we call local because it is greater than in a small interval. I mean, this value is greater than the values around a. I mean, if you pick a small interval around a, that means a minus delta to a plus delta, then this is the greatest value, both sides, right? If a minus delta to a plus delta, if you check, then this is the greatest value. But if you keep increasing the interval both sides, then you can see graph is going up. This value is not the greatest value, right? Then this local maximum again. I mean, see, this is a local maxima. Then it is going down. Then again local maxima might come. Then again local maxima might come, right? So you can see local maxima, if you compare, they are increasing, right? If they ask you global maxima or maximum value, then we compare all the local maximas, because this is a local maxima. It is greater than the values around the interval. I mean, around this point x1. Similarly, this is the local maximum value around the point x2, and this is the local maximum value around the point x3, right? So if you need to find the greatest value, then you need to compare all the local maximas. All right, हाँ, एक particular locality में, you can say that. Nice word. Okay, and for local minima, condition will be reversed if f of a is smaller than f of a minus and greater than also smaller than, sorry, f of a plus, then fx has local minima at x is equal to a. Okay, so in this case graphs will be like this. You can make this graph. This is one example. You can make this graph. This is another example. We can make continuous graph with corner not differentiable. This is also, you can make a differentiable function also. This is a point of local max minima. Okay, and you can also make something like this. X is equal to a. This is the point, say. Okay, hi Parshva. So can you see in all these cases, we can see local minima at this point, x is equal to a, at this point, x is equal to a, at this point, x is equal to a, and at this point, x is equal to a, and this point, x is equal to a. Okay. Got it? All right. Now I'll give you some examples. You need to find whether function has local maxima or local minima, or it is increasing, or it has nothing. Okay, one more point. If function has local maxima or local minima, both, okay, local maxima or local minima, then these 2 points are called extrema. That means if he's saying then find the extremas, that means he is asking for local maxima or local minima. Extrema means local maxima or local minima both. So if he is asking you to count local number of extremas in a particular interval, then you need to count minima and maxima both, local maxima and local minima both. Now I'll talk about the interval also, but first I'll give you some examples. I'll ask you some examples. You need to find, you need to check whether function has local maxima or minima at that point. Okay, I'm going to give you. So first is fx is equal to 1 upon x square plus 1 at x is equal to 0. Okay, you need to answer these questions. Fx is equal to 1 upon 2 raised to x square plus 4 at x is equal to 0. Third, fx is equal to fractional part of x at x is equal to any integer. 4, fx is equal to fractional part of sine x with at x fx is equal to fractional part of sine x at x is equal to pi by 2. Now it is fifth, fx is equal to greatest integer of 1 upon x square plus 1 at x is equal to 0. Sixth, fx is equal to fractional part of 1 upon x square plus 1 at x is equal to 0. Be careful. All these questions are conceptual questions. No calculation at all. Now, Raghav, you know the graph, so you should answer these questions properly. 1 upon x square plus 0.5 at x is equal to 0. Okay, so answer these questions first. GL left 11B GS है ना. She has a YouTube name with class section. Maxima, minima, or maybe nothing. Okay, if it is if it has neither maxima nor minima, then you can write none of these. Okay, NOD, NOD. Answer like this: one maxima, two minima, three none of these, four maxima, something like this. First is maxima, you're saying, huh? Yes, that is right. You know this function is a, I'll make the graph, okay? Graph of what? I'll make the graph of all the functions. So graph of first is like this. It is an even function and decreasing for positive x and increasing for negative x. So it has maxima at x is equal to 0. This is 0 comma 1. Correct. Maxima. Local maxima. Fractional part of x only. Fractional part. Third में fractional part of x. Second you are saying maxima, okay. Okay, then let's begin. Second is of course same because 2 raised to x square is increasing function for positive x. So 2 raised to x square plus 4 will also be increasing and 1 upon that will be decreasing. So its graph will look like similar to graph 1. Like this only. When x approaches to infinity or minus infinity, you can see fx will approach to 0. So it has a maxima. Okay. Graph of first and second are similar. They will look like same. Alright. So this is also local maxima. Now what about the third? Uh, just wait for a moment. Just wait for a moment. I'm taking back. You there? And there was some error actually. It was hanging. PPT was not working. Now it seems all right. Okay, so fractional part, the third was wrong. Your third answer was wrong. Why? Because you can see if you want to check at x is equal to 1, then at x is equal to 1, this is the value. F of 1 is 0. And f of 1 plus right hand limit you can check is more than, and left hand limit is 1. So this is a minima, na? The minima. This point is local minima. Joe, got it? Raghav? Next is you're saying maximum fractional part of sin x. Oh, that is also wrong. Fractional part of sin x if you want to plot. Yeah, oh, you haven't seen my last video of transformation of fractional part function? Huh? You haven't seen? I have taken 7 sessions. Seventh session is on fractional part. So if you plot the fractional part of sin x, because sin x is less than 1, so its fractional part will remain same. But at x is equal to pi by 2, fractional part of pi by 2, fractional part of 1, because at x is equal to pi by 2, sin x is 1. Fractional part of integer is 0. So fractional part of sin x will be 0 when x is equal to pi by 2. You was still 5. Now you should. Now you should watch 6 and 7 also. That's why you are doing a mistake in this, okay? This is the graph of fractional part of sin x. Fractional part of sin x. Got it? So what is this now? What is this? At x is equal to pi by 2. Now you can see the graph. So this is what? Local maxima, local minima. Minima, right? So this is local minima, right? Clearly. And now answer this. Huh? So we are done with these 4. Now answer this. Fifth. Maxima. Yeah. So when you take greatest integer of this you need to take greatest integer of this part. Okay. So greatest integer of 1 will remain 1, and then greatest integer of remaining part will become 0 because everything, all these values are less than 1, right? You can see the first graph. All these values are less than 1. So greatest integer of these values will be 0. So of course clearly we can see this is a maxima, right? Local maxima. In fact, there is global maxima also. So local maxima, alright? Done. Now remaining two. Now be careful in this, okay? Fractional part of 1 plus. Now you need to take, you have taken greatest integer. Now you need to take fractional part of this. So you have watched till 5. In 6th it was transformation of greatest integer functions due to greatest integer function. And in 7th it was transformation due to fractional part function, okay? So go and watch those. I think I have taken 8. फ्रैक्शनल पार्ट के 2 होंगे शायद, और मे बी ग्रेटेस्ट इंडिया के 2 होंगे. सो 5, 6, 7, 8 और देख लेना. So what's the answer of 6th one? What is the answer of 6? Minima. Okay. So fractional part of this. Now you need to take fractional part of this. So fractional part of remaining part will remain, fractional part of all these values will remain same except this value, because this value is 1 actually. So one fractional part of 1 will become 0, similar to this graph, right? And all remaining, all the values of 1 upon x square plus 1, all the values for non-zero x are less than 1. So their fractional part will remain same, because fractional part of x is x when x is less than 1 and more than 0 of course. And fractional part of integer is 0. So fractional part, because 1 upon x square plus 1 is integer x at x is equal to 0. So its fractional part will become 0. So now clearly we can see it is local minima, alright. Now the last one, be careful. Yeah, global minima also, yeah. True. It is also global minima. That means the least value. Yes. So last one, if you draw the graph of y is equal to 1 upon x square plus 0.5. So you see, if you draw the graph of 1 upon x square plus k, the graph will look like same. The graph of this function, this like this, right? But this maximum value will keep changing depending on the value of k. So because k is 0.5, so this maximum value will be 0.5, right? So you can see this whole graph is less than 1. So its fractional part is going to be same actually. So graph of this is same as the graph of 1 upon. This is nothing but 1 upon x square plus 0.5. Why? Because this whole, all these values are less than 1. So no change by putting fractional part function. The same graph. So yes, very nice. Local maxima. In fact, global maxima also, right? Now you understood the concept, right? Concept of local maxima and local minima. Yes. Then we can do, then we can learn other method for differentiable function. So if fx is a differentiable function, okay? Differentiable function at x is equal to a such that f dash a is equal to 0, f dash is 0 and f dash x changes its sign about x is equal to a. Okay, sign change करना is important. That means if you plot the number line and this is x is equal to a, then it at this point f dash x is 0. Okay, at this point, but before this it is positive and after this it is negative. Okay, then this point has local maxima. Positive to negative sign change होगा. This is case 1. If sign changes from positive to negative, then fx is local maxima at x is equal to a. Because graph क्या होगा? Graph will, you can see graph of fx will be increasing because f dash is positive. Then it will be flat at x is equal to a, and then it will start decreasing, right? So graph will be like this, increasing and decreasing. So obviously you'll get local maxima. Understood this? And in the second case, if sign changes from negative to positive, that means at x is equal to a, f dash a is 0, but before x is equal to a, f dash x is negative sign and after x is equal to a, it has positive sign. Okay, so that means this means fx has local minima at x is equal to a. So graph is first decreasing and then it is increasing. Got it? Sign change is important. If sign does not change, then it won't be local maxima or minima. It won't be extrema. There's another way of checking this sign change की जगह पे you can check sign of f double dash, second derivative test. If second fails, then third derivative, fourth derivative, nth derivative test we call it. So I'll tell you that later. First, let's apply by doing sign change only. So find the points of local maxima for fx, where fx is equal to 0 to x square t minus 1, t minus 2, t minus 4. Okay, dt. I will be taking yeah, take some other topic basically. Let's see which topic. You will complete you will even complete your integration during Diwali also, okay? During Diwali, and take 2 more days. After that, we'll continue that differential equation. Maybe from 18 and 19 we can start. No voice, there's no voice line. Just forward. Voice line again. Let me check. Is there any voice line? No. Oh, voice disturbance. Okay. Sorry. I have to check it. Sometimes it happens. Now is it okay? Now is it okay? Yeah. Hmm. What am I doing? This was the question. All right, let's see. I'll try to finish. I'll take 2-3 sessions of that. But AOD will go on up to 18. You start your integration during Diwali, okay? For 2-3 days. Today is what? Today, no, AOD will be finished. I'll take inverse trigonometric functions or some other topic maybe. I'll plan it. You do this sum. Tell me the points of local maxima. See, points of local maxima mean you need to tell me the values where this local maximum will occur, not the values of local maxima, okay? Value of local maxima means you need to find this f of a. And point of local maxima means you need to find x is equal to a. Are you understanding difference between these two? Point of local maxima and value of local maxima. First, you need to differentiate this. Do you know how to differentiate? I told you yesterday also. F dash x is equal to, first you substitute, yes, x square substitute करेंगे and differentiation of x square. Yes, yes, yes. Got the point? Okay, I'll write the derivative then. So its derivative is x square minus 1 into x square minus 4 into differentiation of upper limit, that is 2x, and lower limit is a constant, so minus of lower limit वाला term 0 आएगा. So this is the derivative. Now if you plot, then you can see the critical points. So critical points as minus 2, minus 1, 0, 1 and 2. And if you plot the sign of f dash, then it is plus, minus, plus, minus, plus, minus. So at all these critical points, you can see f dash x is 0 at minus 2, minus 1, 0, 1 and 2. And now just have a look at sign. I mean just check the sign change. So negative to positive, matlab this is minima. And once you have got the minima and function is continuous, then minima and maxima will be alternate. Okay. So next is going to be maxima. Then again it is going to be minima. Then again it is going to be maxima. Then again it is going to be minima. All right. So these are the points of local maxima. 2 points of local maxima and 3 points of local minima. Got it? Raga, you got it? When you have a lot of critical points, just plot on the number line and just plot the sign of f dash. Then you'll come to know that sign from left side. Start from left side and check where the sign changes from minus to positive or plus to negative. If it changes from negative to positive, then that point is minima. And if changes from positive to negative, then that point is maxima, that critical point. All right, now you got it? X raised to 1 upon x. Find its extrema. Find its extrema. Point of extrema. This is x raised to 1 upon x. No point? How is that possible? This is always is it always increasing? Let me check. So you can write fx is equal to ln of this is e raised to 1 upon x ln x, right? So we'll differentiate it. It is going to be x raised to 1 upon x, and differentiation of this function, which is 1 upon x square minus ln x upon x square, right? Is that all right? Now you can see it is x raised to 1 upon x, 1 minus ln x divided by x square. You know, domain of this function is all positive real numbers. Domain of f raised to g, fx raised to gx is all those values of x where fx is more than 0, right? Base should be positive. Have you understood this? Derivative समझ आया क्या ये? I can see derivative is 0 at some point. What is that point? Can you see that? If you put this is equal to 0, then this number is a positive number correct? This number is also a positive number. This can be 0, right? So this means 1 minus ln x is equal to 0. Hence we'll get ln x is equal to e. X is equal to e. समझा? X is equal to e. X is equal to e is the point. And now at x is equal to e, f dash e is 0, right? We have got this, f dash e is equal to 0. Now you need to check the sign change. So at x is equal to e, you can see after e, ln x will be more than 1. So f dash will be negative. And before that it will be positive. You can see 1 minus ln x will be negative when ln x is more than 1 or x is more than e, because ln x is increasing function. So that we have got that function is first increasing and then it is decreasing, right? If you want to draw the graph of this function, then what you need to do is rough sketch, obviously, because concavity we are not going to focus, and without concavity we can draw the graph. We just need to find the limits of this function when x approaches to 0 and when x approaches to infinity. So when x approaches to 0, x raised to 1 upon x. You can see this is 0 plus, okay? Right side of 0. So 0 plus raised to infinity. 0 plus raised to infinity, what is this limit? Can you tell me, Raghav? 0 plus raised to infinity, what is this limit? Tell me fast. Oh, what's your answer? No, it's not 1. That is 0 raised to 0. X raised to x. X approaching to 0 plus. That was 1. This is not 1. 0 raised to infinity. It's 0 plus means it's a very small number and you are multiplying this number infinite times to itself. What will it be? Tell me. It's a logical one. This is not indeterminate, beta. 0 raised to infinity is not indeterminate. 0. Yeah, it is 0. This limit is approaching to 0. Similarly, when x approaches to infinity, can you tell me? X raised to 1 upon x. Now this is it indeterminate? Tell me, is it indeterminate? Infinity raised. This is infinity raised to 0, right? So yes, 0 raised to 0 and infinity raised to 0. These are indeterminate forms, okay? So if you find the limit of this by taking log the same way, you can write e raised to 1 upon x ln x, okay? X approaching to infinity. So x approaching to infinity, this approaches to 0 because log x is very small compared to any polynomial when x is very large. So log x is smaller than x. So when you divide log x by x, it will approach to 0. Even you can apply LH rule. So ln x upon x is 0 when x approaches to infinity. So it is e raised to 0. That means 1. Have you got these limits? Why am I plotting these limits? I'll tell you. I'm plotting these limits so just to tell you that from where this graph will start. So this graph will start from 0, okay? Then it is increasing, so it will go up. Okay, I'm just taking a rough sketch. I'm not taking care of concavity because for that I need double derivative and then I can answer concavity. It will go like this or like this, okay? It will go like this or like this, okay? That we are not concerned. So I'm just taking any one, and then it will be decreasing after e and decreasing, but because you can see when x approaching to infinity, y approaches to a finite number. That means this graph will become horizontal. Then only it will approach to a finite number. That means there's a horizontal asymptote also, and that asymptote is y is equal to 1. Okay. So graph is going to look like this. This is one. So there's a maxima, there's a local maxima, which is also the global maxima at x is equal to e. So what is that local maxima? What is the maximum value of this function? E raised to 1 upon e. Okay. So f maximum or greatest value is basically e raised to 1 upon e. And the point of local maxima is, what is the point of local maxima? Point of local maxima, or in fact global maxima, दोनों same है, is equal is e, x is equal to e, right? Clear? All right. All right. Now I'll tell you local, extrema, extremas and global maxima, minima in closed interval a to b. Okay, we just need to understand the end points. It is related to end points, nothing else. So suppose I'll just give you one graph, and through graph we'll understand this concept, global maxima concept. Okay, concept of global maxima. Yes, that graph was like equilibrium. Yeah. Unstable equilibrium. Okay. So global maxima, minima. See, we are discussing this graph in a closed interval. That means endpoints will always be considered. So whenever endpoint is considered, the graph is starting from this point. If graph is starting from this point and it goes down, okay, it goes down. Then, and this is the starting point of domain, okay, this is the starting point of domain. X is equal to a. Then this is called local maxima. You just compare it with only one side limit, right side limit. So yes, of course, it is greater than right side limit. So it is local maxima. You got this point? But suppose case would have been like this. At x is equal to a. Graph start from this point and it goes up. It goes up. Then this point will be local minima, point of local minima. That means at the end points there will be either local maxima or local minima if it is not a constant function. ओके देखो, जब हम इंटरवल में बात कर रहे हैं ना, तो स्टार्टिंग पॉइंट्स और स्टार्टिंग पॉइंट एंड एंड पॉइंट पे लोकल मैक्सिमा कैसे आएगा? वी विल कंपेयर दिस वैल्यू ओनली विद वन साइड लिमिट. ओके, स्टार्टिंग पॉइंट पे राइट साइड लिमिट से कंपेयर करेंगे. सो इफ इट इज ग्रेटर देन द राइट साइड लिमिट, दैट मीन्स इफ f of a is greater than f of a plus, then it is local maxima. Okay, and if f of a is less than f of a plus, then it is local minima. You got it? ये समझ आया? Now suppose this graph comes up, down, comes up, and then again in the end it ends like this. Okay, so again at the end point x is equal to b, we will compare this value with its left hand limit. So if f of b is greater than f of b minus, okay, then it is local maxima at b. All right. And if graph ends like this, okay, might end like this. So if graph ends like this and x is equal to b, then clearly you can see f of b is smaller than f of b minus, right? Then it is local minima at x is equal to b. So I think you have understood the concept. एंड पॉइंट्स पे या तो लोकल मैक्सिमा होगा या लोकल मिनिमा होगा इफ इट इज क्लोज्ड इंटरवल. ओके, इट विल ऑलवेज हैव आइदर लोकल मैक्सिमा और लोकल मिनिमा if it is a closed interval. And अगर open interval है तो of course we are not going to consider these points A and B because these points are not in the domain. Then there's no point of discussion of local maxima and minima at x is equal to A and B if it is open interval. Okay. For some time, maybe 10, 15 minutes, 20 minutes. Let me finish it. Are you in a hurry? Shall we continue? Okay, so let me finish this one. Okay, in 5 minutes. So if graph is like this, then we will continue tomorrow. Graph is like this, comes down, goes up, comes down, goes up. Okay, and like this, ends like this. So you can see this is local maxima, local minima. This is local maxima. This is local maxima, and this is also local maxima, right? So basically, global maxima, global maximum value is equal to global maximum value कहाँ पे होगी? जहाँ पे सारे लोकल मैक्सिमा में जो सबसे ग्रेटेस्ट होगा. That means maximum of all the local minima, like in this case you can see say this point is x1, say this point is x2, and end point we know, and this function is fx. So that means in this case it is f of x1 comma f of x2 comma b, right? So इनमें से जो greatest होगा that will be local maxima, say, or global maxima or greatest value, and global minimum value is equal to minimum of all the local minima. As simple as that. Like in this case, if I consider this x3 and x4 and a, then it is f of a comma f of x3 comma f of x4, and according to these graphs let me circle the global maxima. कहाँ पे आएगा global maxima? Tell me. According to this graph. Okay, according to this graph कहाँ पे आएगा local maxima? In this graph I'm going to circle that. No, I'll correct that. This is maxima. Okay. हाँ, बताओ कहाँ पे आएगा? Where will be global maxima in this graph, the given graph? B पे, yeah, it will be at B, right? Very true. And where will be global minima? Least value. Whatever you can see in this graph, which is clearly visible. This is a minima. This is a minima. x4, very true. This is local, global. This is a least value, global minima, and this global maxima. All right. This was in the closed interval. Now tomorrow we'll continue about open interval. Okay. So tomorrow I'll tell you about open interval. And open interval concept is very important, because sometimes it might happen that global maxima or global minima might not exist. In this case, they will exist always. In closed interval, they will always exist if function is continuous. If function is continuous and interval is closed, then global maxima and global will always exist. But if it is open interval, then global maxima or global minima might not exist. Like from straight lines. Straight lines? Straight lines? No, 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 no. That is different thing. I'll explain that tomorrow, okay? I'll explain that tomorrow. Not like straight lines. It's a different thing I'm talking about. I'll explain it tomorrow, okay? So let's end this session today. We'll continue tomorrow. ठीक है? क्या कह रहे हो? Like from straight lines. Oh, okay. अच्छा. I'll think about it, okay? I'll think about it. All right. Your suggestion noted, okay? Chalo, take care. Bye bye. I'm ending the session here then.